Good day and welcome to my C++ channel. Today topic will be cache, C++ cache, using the concept of least recently used cache. We can start directly into the code, C++ code, of course. So in C++ there's a lot of data structures, such as we do have list, vector, stack, and queues. And we do have nonlinear data structures such as map and unordered map or the red map and sets. So we can use all those data structures and try to find the best way to build our cache. And the best way to do that, you can use a vector, for instance. But when using a vector, if you want to switch data or extract, because a cache, basically least recently cache is the concept of it is if you store the data into that cache and you keep adding other data, and you decide to store the same data again, but you want to access it as soon as possible, as fast as possible, will be the top of the cache, definitely. But the thing is, by doing that, this requires a lot of manipulation if you use vectors. And what is ask yourself, what is the best data structure that I can use to have the best outcome, best performance possible, and less complicated possible as well for programming, of course. And to do that, what I recommend is to combine linked list and a hash table. So when you have these data structures, C++ data structures here, C++ data structures, we do have here a list, a vector, stack, and queue. And the best way to use the linked list would be using the list here. So the concept of the implementation of list is linked list. To be precise, is doubly linked list. And we can use hash tables. For instance, we have a map here, or an ordered map here, or a set. Uh, I recommend to use an ordered map, and I will explain you the reason why. So let's get started. I'm going to create a new file, call it LRU, uh, yeah, LRU cache, let's say cache.hpp. Let's start. We're gonna have f-nodef LRU cache hpp. Then we define cache p and f. There you go. That should be fine. So to use a cache, we want to store data with the key and values. So we can start creating our class LRU cache, and here we're gonna make it a template. We want to store uh, the key and values. Okay, and we have here public members and private members. So as we discussed, to do that, we're going to be combining list and unordered unordered map. So what's going to happen? What is the content of the list? The list will contain a key and an element, or a key and a value. Let's put the value here, value, and so on. Be pointing to the next, let's say here, key one, value one, and this pointing the next key two, value two, and so on. Point to the key three, value three, and so on to key n and value n. And a map, an ordered map. Why I use an ordered map? Because I want to have a structure that it could be able to access much faster element here. Because if I want to access the third element in a list, when I have a linked list, I have to navigate through every element to get that value here. But if I'm able to use another data structures that can be accessing to that element much faster, so I will be accessing that element here and be able to switch it and put it on the top. So that's the concept of cache, be able to access the list recently used element. And because I'm using the list recently used concept, can use also LFU, list frequently used element. And here the reason I decided to on order map, so we'll be able to access to that value much faster. So here we have an order map. The order map will contain a key one, for instance, but instead doesn't contain a value, but contain a reference to that element, how I can access to that element. I'm gonna be using an iterator. So I will be accessing to the first iterator of this list. So let's call it iterator one. And my second element, since there is no relation between the first and the second, so will contain the second element here, key 2, will be pointing to the iterator to the second iterator of the list, and so on. The third element, key 3, will be pointing to the will contain a value of iterate, will have the value as the iterator 3, the third iterator here, and so on. Keep going until the end. That will be pointing to the last element. So we can just write here list end, and here will be list begin, list that begin, and so on. So on the next element, and so on. So that's the concept of how I will be building a cache properly. So from there, I will be able to store all my data of the list according to the size of my cache that I want to set, and I will be able to access to the element using by another data structure, another the map that will contain the key and the iterators that I want to have here. So let's get started. So I'm gonna first include a list, and I will be including an ordered map. So for those people who don't know what is the difference between map and ordered map is the uh, the implementation itself. So a map, it's a binary tree implementation. So when you store data in a map, everything will be stored in order. So the implementation is based on a binary tree, to be precise, red, black, balanced tree, and an order map is built in implementation inside is a cache basically. So element element are stored randomly there, and according to the key value there. There is I'm not going through the details there, but it's that's the difference. So if you want to access element much faster, it's better to use an ordered map. But if you want to store data in order, it's good to have a map there. So I'm going to use an order map here. So I'm gonna have a class, LRU cache here, that will hold uh, my map, a list. I'm gonna have a list here, a list, std list, and the list will contain a key and value. So I'm gonna have a pair. Let's define a pair here. Type def std pair. We're gonna have a pair of a key and a value. Let's call it pair, set this. And here probably we need to include utility. There you go. So here we're gonna have element of a pair. Let's call it my list. And our cache will have also a size, predefined size. Let's call it here my size. There you go. Default size will be 0, and I have my list, and I'm gonna add my an ordered map that will have a key as an element, first element, and the second will be an iterator of my list. So std list pair this time, and here I'm gonna have iterator. Okay, and my unordered map. There you go. So this is the data that I need pretty much in my cache. So I'm gonna have a constructor here. Let's explicit LRU cache, which will have predefined. Sorry guys, size here. My size will have size element, and I'm gonna have explicit, and here I'm gonna have my the structures, default one. So a cache will contain two functionalities to get the data and insert data. So, but when you want to get data, you want to return a value, but sometimes the value does not exist, so you will not return anything. So I recommend to use optional here. Again, for people who are not familiar with optional, I recommend to look into STD library definition implementation of optional. So why use optional? But you can use other um, return type if you want to. So here I'm going to have two functions. My first function will return an optional of value, which is get. And to get, I'm going to insert, um, I'm going to get via a key. So I have a key here, say key value here. I'm going to implement these functions, and I have insert function, which will insert the data and will be inserting by key and value. So I'm gonna have key here and value. So will be those are the two functionality that I want to have in my cache. So let's start with the easiest one, which is the get functions. I want to get the element that is on my list. So to do that, I'm going to check into the map if the key is there or not. So that's the reason why I decided to combine both data structures. If I didn't have a map, then I will be traveling through the whole list, which is okay if the data if you don't have a lot of data. But imagine if your cache contained 10,000 of data, that will be really long, really. I mean, performance will not be that good because you will be traveling until you find the appropriate key. So I'm going to reduce the complexity from ON to O1 by using another data structure, which is another map here. So let's go for the implementation. I'm going to try to find the data. Let's say call it like found. So we found it. Send my another map, and we use the function find. Find a key. So what happened if we found it? So we're going to have an if statement here. If found is not equal to my honored map dot end, then we just return the element. We're going to return what? Found, which is it's an iterator. We looked at the second element, which is also an iterator, but of the list. So it's the iterator of this list. So that we return the first iterator is this, and we return the second element, which is iterator of that, and we need to return the second element again. So second, we get the data. Otherwise, if we don't find the data, we just return std null channel, not opti. There you go. Okay, and now this is our get functions. Now we go to the insert functions. So to insert the data, we start first by verifying the current size of our list. So cd size t current size, which is my list size, and we check if the key is already there. So found equal to unordered map, type find the key, and we do our verification here. So if found is not equal to map dot end, when we do what we have to do, otherwise we we if the if the key is there, then we have to put it at the top of the list. If it's not, then we have to insert it. So to insert element first, we need to insert, let's go to the easiest part, which is inserting the element. But to verify first before inserting, we know that we want to have our cache to a specific size. We want, let's say, to have a size of 5, then we shouldn't be exceeding the current size should not exceed 5, which is the size has been defined in the constructor here. So let's do that. So we are going to check if the current size is equal is not equal is equal than size than my size. If it's equal than my size, what we're gonna do? Then we need to remove the last element, right? So let's do let's do this. We want to find the last element. So we are going to have auto, let's say, call it back equal my last element, which is list dot back list dot back. So this function will access to the last element. So we have our last element here. And what we're gonna do with it, we're going to extract get the key. So can I do? We are going to first erase the key from the map, the element from the map. So my another map dot erase. What we're gonna do? Erase back dot first, which is the key. Then we erase the element from the map, and we need to remove the last element from it. Since we know that this element is no longer needed, and because here we know that the key is not found, that means this is a new element. So the last element will need to be removed from the list. To remove that, we do my list that pop back like this. Not sure. I think this is the right pop back. Yeah, pop back like this. There you go. My list. So when we are done with that, now we need to insert our new element. So I'm going to insert my list that push front. I'm going to use a push front, and here I'm going to push my new element. Sd make a pair of what of a key and value. That's my list. Since this is the first, so this, when doing push front, I'm pushing to the top of the list, and now I need to update my map as well. That insert, I'm going to insert. What I'm going to insert is a pair. This will contain will contain a key and a value. So I'm going to again here std make pair of a key, but not a value this time. I'm pointing not only to the key, as we discussed, we're not pointing to the value. We need to point to the iterator, the first iterator, and here will be my list begin. Because the element here is on the top of the list, the first element of the list. So the iterator will be just my list begin. And that should be fine for when the key is not found in the map. So in case of the key is found, then we have to do something here. So what we need to do first is to update the value of our list, because we insert the same list may have different values. So we need to update. So if we found the element, so found, we point the second element, which is the iterator here, and we go again to the second to update the value. Second equal to the new value. That's one thing, right? So from the second element, we have the list iterator, and since the content of the list is a pair as well, then we point to the second element again, value 1. So here, what we need to do, so that's what we did. And now we don't need to update the map, because the map is pointing to the iterator. So we just need to ensure that the element is on the top of the list. So how to do that? I'm going to use a function of std list library, which is splice list dot splice, and I'm going to move my iterator, the list iterator, into the beginning of the list. To do that, so I'm going to specify the position list dot begin, and here I'm going to use my list, and the element, the iterator, the current iterator found is defined here by found second element, which is the iterator. So I won't go in detail how splice is working, but you can look up into the stdlib website. You will be able to understand what are those three. There's an example there explaining how to use the function splice. Quite used, and that's the reason why I decided to use splice a list instead of a vector to take advantage of this functionality here. And I think that is pretty much what we need for cache. And this make it look okay. We can go for testing. We can go for testing, definitely. We're gonna save that. And I'm going to my main CBP here, and I'm going to include my LRU cache HPP. I'm gonna add another functionality. So let me just verify if it compiles. LRU cache, LRU for instance. I'm gonna have, let's say, 5 element. Okay, uh, that should be fine. And here we want to have, let's an example, integer, and we will be pointing to string or let's say string, std string. Okay, for instance. Okay, we're going to add, maybe we need string here, std include string. Okay, and let's test this. I'm going to create a loop for I0, start from I less than 20 element, for instance, and I'm going to increase that. LRU dot insert key. Let's say key here will be the value, and value I can put whatever I want. String, let's say hello, and let's verify if this will compile. So we have insert function. Let's see if it's compiled. On terminal, ask what we have here. Inside integer. Yeah, of course, it's inside integer. Let's integer gonna back a value tables. Okay, so we have this x, and we can have, okay, see the top of list here. Okay, has not been declared. Oh, okay, we have insert function issue here. We have capital Y, and here, what else? Roadmap, what's going on? Iterator, my list, pair, which is the key, is the key value pair. That's fine. What we got here, let's just verify on a task. Task. Okay. Is the problem. Okay, volume mismatch at second template. For instance, oh, maybe is why volume mismatch second template, or the expected type. Oh, okay. This could be, it could be, happen. Oh yeah, let's type name definitely here, probably, because this doesn't think that should be okay, because let's type name. This is a pair, task. Okay, that's better. And here cannot bind on constant value. Left value reference to std basic. Let's go to the main here. Maybe what we can do, std string. This, that should be, is it a constant value? Not sure if this is a constant. Constant value. Good. That should be just for the sake of this presentations. Let me verify again. I'm going to clear this. Yes. Again, that should compile correctly. Okay, successful. Good. Now I need to print the data here. I'm going to use an operator here. I'm going to include IO stream, and here std IO stream operator slash and std IO really stream, not input, but here it's stream, not IO stream, stream, yeah, IO stream. And here, sorry, here I'm going back reference out, and I'm going to take LRU as a constant here, LRU cahche, and here I'm going to have an integer to be precise, and string, right, string, and I will be able to print my LRU cahche here. So to be able to do that, I have to make sure this function is friend of my LRU cahche. Otherwise, I wouldn't be able to access to the private element that I have here. So I'm gonna just copy this function, Control C. I go to my function here. I'm gonna make it friend. Control V. Stream operator. There you go. That should be fun. Okay. Let's compile this. Let's go on. Stream, it's stream. CD. Yeah, it's stream. That doesn't return a type. Okay, let's print first. Out for I want to access the element of my list, so constant auto element of my LRU dot list, my list, and here I will be printing the elements. So to print that, I'm going to out. I'm going to print this. So element here, going just to fix the issue here, will be something like this. My list. So I have my list element first will be the key, and that is pointing to a value here, and will be element second, which is the value, and switch line. That should be okay. What's going on here? Should be accessible because yeah, it's a mistake here. I stream. It should be I stream. Sorry, my mistake. It should be all stream. Yeah, it's an output out stream. STD all stream, STD all stream, and that should be output, and it should be out, out. That should be fine. STD all streams is an output all stream. That should be fine. And here all stream, yeah. And here I'm going to return first, and element. And this is my list, LRU cache. So if you go to the LRU cache, and I have my list here, my list. Okay, that should be okay. That is correct. All stream, correct. That is all stream. LRU cache. I have the list by this. And here probably include IO stream. IO stream. There you go. Sorry for that. That's just small box. First context. Okay, good. Okay, perfect. And here, this is the second element. Second element. So again, okay, perfect. That looks okay. Okay, and now I'm going to print my LRU cache std cout LRU. That should be fine. Okay, that build that. That should be okay. And good. Let's try it here. To the ls, created my HPP, my main CPP, and I have my executable here. So to be able to generate that, I don't need to go in details, but if you use VS Code, you have a task here explaining what are the output that I want to get. So here is my executable. So I will be running the executable main.ext, and this is, as we agreed, that the size is 5. So the last 10 elements, let's say next time, needs to have less than equal. So if I build again, run task, it's successful, and run again, and you have like the last 5 elements. And if I want to if I want to insert an element, I'll use that insert, let's say 17 again, 17 as a key, and this time I want to have the value hello world, and I'm expecting to see the 17 on the top of my list, right? So let's verify that. My task. Yeah, it's a reference, so it's an R value here. So let's nt value 17, and here value insert, and terminal run task. Good. And here, if I run it again, did this compiled? Insert. Yeah, I need to print it. LRU cd cout LRU. Okay, let's verify that. Compiled. Good. And run again. As you can see here, my let me just separate the list. Line. Okay, there you go. So I have my list. So I've been inserting element, and the size of my list is 5. So I'm expecting to see. Actually, I think the size is one. I have 5 element here. So the size is 5. So the last 5 element will be 20 from 16 to 20. The top of the list will be 20, right? And because I'm inserting data, so the least recently used is 20 and so on until 16. Now I insert a new value. Now the 17, which has different value, need to be on the top of my list. So the 17 here goes on the top. So it goes on the top and you have 20, 19, 18, 16. So we move, since we used 17 recently, we inserted new data in it. So we move it to the top of the list. So this is pretty much an LRU cache in C++, easiest way to implement that, much faster in terms of performance, as well accessing the data and manipulating the data there, inserting new data as well according to the size. Yeah, hopefully you like that, and we'll be doing other videos. Probably the next videos will be how to build a thread pool. Be working on that. Thank you very much.